Alright, well, we're going to try and construct a triangle when we know all three sides of that triangle, how long they are. We call this side, side, side triangle because, of course, we've been given all three sides and the information about those three sides. So it tells me here I want to construct a triangle ROB, and those letters are the letters that will be at each corner or vertex of the triangle R, O, and B. And I want to know that the line between R and O is 7 centimeters, the line between O and B will be 4 centimeters, and the line between R and B is 60 millimeters. So that's all the information I need. And like we said, this is a side, side, side triangle because we're given all three sides. A really, really important thing for me to do is to sketch the information that I've been given so that I have an idea of what the triangle is going to look like and where the measurements are going to be. It doesn't really necessarily matter that the sketch looks exactly like the actual triangle turns out. But what's important is that I label the information. So I usually start with the longest side down along the bottom here. So this will be R, O. So this side from R to O should be 7 centimeters. And since it's a triangle ROB, the B has to be up here at this other third corner. So line OB, so that's this one, should be 4 centimeters. And line RB, right here, should be 60 millimeters. Now I threw this in here on purpose because kids often don't pay attention to the measurements that they're given. These two are given in centimeters, that one's in millimeters. I can also know that 60 millimeters is the same thing as 6 centimeters. That's important for me to be able to know that. Okay, so I can use either of these. It's the same thing. So now I've got it sketched, so I know I have an idea of what I'm going to be doing and how I can start and what the measurements should be. So I'm going to start with this baseline here, RO, the smallest. So I'm going to start down here someplace because I'm going to give myself room to build the triangle up here. Okay? So I'm just going to put my ruler down and I'm going to make a nice straight line that is 7 centimeters long. I want to be as precise as I can. When I make that line, there we go, 7 centimeters, and I'm going to label it. There's R, there's O, and it's 7 centimeters long. Okay. Now, I want to figure out where this line B is, where this point B is. I know it's up here somewhere. I know it's 60 millimeters from here, and it's 4 centimeters from here. What kids often will do is they'll try to just guess. They'll try to make a line here 6 centimeters long. Maybe this is faintly. They'll just guess. There's 6 centimeters. And then try to go and attach it to the other side. Oh, it's too short. That's supposed to be 4 centimeters, but it isn't. So they try and erase it. And they'll try again until they get close. Okay, oh, maybe I'll go and do 4 centimeters here. There we go. And hopefully this is 6. Well, it's not quite 6. So we try again. This is not the correct way to do this. Okay? When we do side, side, side triangles, we're going to use a ruler and a compass. The compass is important because it's going to tell me exactly where this point B is going to be located up here above line RO. It's going to find exactly where this point is that's 60 millimeters from R and 4 centimeters from O. Here's how I'm going to do that. I'm going to take my compass and I'm going to center it at this end of the line R. Zoom in there and see if that helps. There we go. I'm going to center my compass at the end of the line with the R's. There we go. Now what I want to do is make an arc up here that is this size in radius, 60 millimeters or 6 centimeters. So I'm going to go ahead and do that. There we go. There's an arc. Now, arc really by itself isn't all that helpful, but what it tells me is everywhere along this arc is 6 centimeters or 60 millimeters away from R. So point B could be anywhere along here. Could be here, could be here, could be here, could be anywhere. But the nice thing is, since it's an arc, it's 6 centimeters all the way along. So everywhere on this line is 6 centimeters or 60 millimeters away from here. That's where, what we know, B has to be 60 millimeters away from R. But it also has to be 4 centimeters away from O. It has to be 4 centimeters from here. So if I draw another arc that's 4 centimeters away from O, I'll find the exact spot that's 60 millimeters from R and 4 centimeters from O. So this time I'm going to put my compass down at the other end of the line, where O is, and I'm going to describe an arc that's 4 centimeters long, or 40 millimeters. I want to remember that's also 40 millimeters because my compass, the safety compass, uses millimeter measurements. So what I'm going to do is describe an arc. There we go. This arc, everywhere along here, is 40 millimeters or 4 centimeters away from O. So the one spot on this entire construction that's exactly 60 millimeters away from R and 4 centimeters away from O is where they cross, where they intersect. So this intersection point is B, right there. Okay? So the compass has made it so that we can exactly pinpoint where the third corner of the triangle is going to be. So the last thing I have to do is very carefully connect the intersection of the arcs to the end of both lines, or to the end of the line at R and the end of the line at O. As carefully as I can. And there we go. We have triangle ROB. That's 7 centimeters. I can measure. This should be 6 centimeters or 60 millimeters, and this should be 4. Looks good there. And looks good there. So I'm going to label these with the information I was given. I'm going to leave these arc lines there for now, because what I tell the kids in class is leave them so that I know that you've used the correct method to build this triangle. I've got all 3 corners labeled with the correct letters. I have all the measurements created. We've got this constructed. We also ask the kids to identify the type of triangle. I'm not talking about a side-side-side triangle. That's a particular construction type or a particular geometric version of a triangle that we have information for. I want to know what kind this is. Scalene, isosceles, equilateral. Is it an acute triangle, an obtuse triangle, or a right triangle? So we have to give it 2 designations. One based on its sides and one based on its angles. Since all 3 sides are different length, that means it's scalene. And by inspecting this, all 3 angles look like they're smaller than 90 degrees, which would make it an acute triangle. And I can verify that real quickly. This one here looks sort of close to 90, so I'd want to check that. But it's smaller than 90 degrees, so that's good. These 2 are also smaller than 90, so it is an acute triangle also. So we have a scalene acute triangle, and it's constructed perfectly. If everyone follows these steps, everyone's triangles will be the exact same size. Okay? Doesn't matter, it could be turned, could be flipped, but it will be exactly the same size as what I built there. The compass makes it a little bit tricky, a little bit difficult to nail down this particular construction method, but there's an example of how you can construct a triangle if you know all three sides. Give yourself 3 other dimensions, make yourself some triangles that you can practice this with.